Here's integrated 3. It's problem 10-149. It says the flat building's roof is 32 feet wide and 60 feet long. An antenna rises 25 feet above the center of the roof, and wires connect the top of the antenna to each corner of the roof and to the midpoint of each edge, as shown in the picture above, or at right. What was the total length of wire used to connect the antenna to the roof without counting any extra needed for attaching it? So they want you to find the lengths of all these wires, add them all up. So there's like 1, 2, 3, 4, 5. I guess there's 8. There's 8 wires. But I see that some of the wires are going to be the same length. Like there's 4 corner wires. I'm going to call those like the diagonal wires. So there's 4 corner wires. So I'm going to go 4 times something. I'm going to find out what one of the corner wires is. So 4 times I'm calling them the diagonals. And then there's 2 of I'm calling these the shorter wires because these midpoint wires are going to be shorter than these other midpoint wires. So there's going to be 2 times the length of the short wires, and then 2 times the length of these longer wires. Okay, that's how we're going to find out the total amount of wire. So how do we find out the total amount of wire? So the first thing I wanted to know, well, I went ahead and just right here, I drew a tiny little model of it, and I know that this is 32 and 60, but I wanted to know this diagonal because that would help me find the 4 corner wires that are going to each corner. So I want this diagonal, and so I drew, see how there's 32 and 60? There's my 32 and my 60, and I did Pythagorean theorem to find the total diagonal all the way across was 68. So, but I don't really want the 68, I want the half of the 68. So I used 34 right here, and I made another triangle right here. This is for my diagonals, the wires that are going to the corners. From there to there is 34, and then the up part is 25. So I did Pythagorean theorem, and I got that the wire that comes from the top down to the corner is going to be 42.2, so I stuck that in here, and I'll multiply it by 4 later. Well, I already did it, but I just stuck that in there, and then I moved on to the next thing. So for the short sides, I drew this other triangle like that, and so it's 16 this way, because the whole thing all the way across was 32, so that's half of 32, that's 16, and then 25 up. So let's see, I did Pythagorean theorem right over here to find out, like that's the top of the antenna, right? And I want to find the diagonal, and it was 29.7. Well, it was 29.68, blah, 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 so I stuck it in there like that. And then I need to find this number. This is for the long way. That's like this way. And so since it's 60 all the way across, then it's going to be 30 halfway across, so 30 by 25. So there's my little triangle for it. I did Pythagorean theorem, and I got that it was 39.05. Then I multiplied this number by 4, got that, multiplied by 2, got that, multiplied by 2, got that, added them all together, and this was the answer to letter A. That's how much wire we need. Now for letter B, I can just use some of my diagrams. Letter B says the wires that attach to the corners of the building form an angle with the roof. So these are the corner wires. That's what they want to know. What's the measure of the angle? So I already have a picture of the corner wires. I called them the diagonals. So I just need, if that's the corner right there. So I just need to know what's that angle. So, and I redrew it down here. So tangent is adjacent over opposite over adjacent. So tangent of theta is opposite over adjacent. So then I can inverse tangent both sides of the equation, and that's canceling out my tangent, and it gives me theta is inverse tangent of 25 over 34. And that, my calculator told me it was about like 36.3233, 36.3 degrees, 36 degrees. And, oh, and then letter C. So letter C is interesting. I was really glad that I happened to do the problem this way, because letter C says, suppose the height of the antenna is X feet instead of 25 feet. Represent the total length of wire in terms of X. So you can see I set mine up already kind of like this. I had four. I knew there was 4 diagonal wires, and there's 2 of the shorter wires and 2 of the longer wires. So it was 4 times the diagonals plus 2 times the shorter ones plus 2 times the longer ones. But I can't use 25 anymore. So how did I get the diagonals? Well, I went 34 squared plus 25 squared equals c squared. Now, I didn't show all my work, but if I square root both sides, I can say, because that was c, right? So I can say it was 34 squared minus x squared. Is that what they had? Oh. Or plus. Sorry, plus. Okay, and then so this one. So you can see how these are maybe going to play out. I'm going to always have, so this was the short side. So this would be 16 squared plus x. Instead of 25, I have to use x. So the square root of, I think they put their x squareds first. It's okay though. And then this one would be, oh, I didn't show my work at all on this one. Let's see, this was square root 30, or 30 squared. Okay, so that, they wanted something like that. And that's it.